Okay, let's pull up the Intro to Computer lecture.
Hey, Dr. States,
Yes.
can you turn off the light 'cause we can't see
Absolutely. Okay. We're going to do the Intro to Computer lecture, and this is just meant to get you thinking about some computer terms, looking at different approaches to understanding computers and so on. Not to make you a programmer or anything else, just to get us all on the same page. So what are computers? Most of us know that these computers are reduced to answering questions, and everything's reduced to a 0 or 1. Or if you think about it, computers say yes and no to everything. They say, is that letter a B? Yes or no. Is it a C? Yes or no. Is it a bold C? Yes or no. Everything's reduced down to a 0 or a 1 or a yes and no. Now the big advantage of a computer is where it may take us seconds to make a decision, they make hundreds of thousands of decisions a second. And that's the speed, that's the processing that we just can't do. Okay, they look at multiple options. Some terminology, sort of the central processing unit, the chip inside, and computer speak is extremely literal. What does the central processing unit do? What does it do? It controls all the processes. Okay, computer people, maybe not the most creative bunch in the world, but they're very direct. The central processing unit processes everything. Okay, fair enough. Software, some people get confused now. Software and apps, sort of the same thing, different size maybe, but they are a set of instructions that tell the computer to do something. Okay, the computer is the infrastructure. It's the machine that runs the instructions. Okay, so computer infrastructure, software, applications are the instructions to carry out your task. This next section we talk about types and. Are desktop computers going away? Probably not. Are tablets going to replace laptops? Maybe, maybe not. I mean, who knows? Are we all going to have a chip in our head like the new guy, the new intelligence TV series where the guy's got a computer in his head? Maybe. Maybe that's next Christmas. That's what you asked for. I want one of those computer chips in my head. Could get worse gifts. So just read through these sections and. So what can you do with a computer? Anything that makes decisions. Think about that. Now, I asked this the other day. Where is the internet? Is it in New York or LA or Stockholm? Really, the internet is what? It's every single computer, every device that's plugged together, right? And there isn't a office. There's some guys who make up some rules, okay, W3C and so on, and they can say if you're going to have a website, the first page needs to be called index, okay? So, but there isn't a body. There's no one that says, oh, you can't put that on the web because it's not true. Did you see the movie Accepted, where the guys create a website for a college and people start applying and sending checks? A couple of good computer design students, and they create a Tracy.edu, come, we accept you for go to university, send us $1,000, and Tracy starts going, okay, come on down. And it looks legitimate, so nobody's going to go on there and say, oh, you can't do that. Okay, there's no internet web police. So, email, yeah, we know that. Instant messaging and Instagram, Vibe, you name it. Whatever the flavor of the week is on the new way of controlling, communicating. Gaming. Some of the things that in education and in public health we're getting into gaming now. We know that a lot of people are kinesthetic learners. They learn from doing and so on. There's a gaming company that's now working on teaching math through using Kinect and physical motion and math principles, and a lot of kids are really coming into that. So you study your math through like dance moves or exercise things. So trying to use more physicality connected to a computer. So, gaming's a lot more than just shooting up cars or whatever. Parts of a computer. We put everything as input and output. Everything. If you think about it that way, it either puts information in or it outputs information. Okay? So that's kind of an easy way to look at it. Monitors, input, output. It's a trick question.
Output.
And input. Why?
Because
Touch screens and so on. Yeah. So it's both. Monitors, input, output. Keyboards, mostly input. The stuff you think about. Speakers, microphones, of course, an input. Printers, output. What about mice?
you say the speaker would be input?
Speakers, output.
Okay.
Microphone, input. What about mice? A mouse?
Input.
It is input, but there's a company working on one that has an output feature to it, and they're trying to make it for the shopping industry. They're trying to put a little motor in it, so like if you're at somewhere buying a sweater and you want to mouse over the sweater and it's got a lot of a heavy wool weave to it or something, the mouse will actually vibrate, bump up and down according to the feel of the sweater. So that's a kind of a neat thing. But of course, like anything else, it will be used for other things than it's designed. So let's not even think about the whole porn industry with that. But anyway, input, output devices. Okay, we come down to the system unit, the CPU, kind of the brain of the system. It's how fast things can happen. Okay. Now on this one, let's talk about this. The leader in chip design, Intel, probably heard of them. For the last so many years, they have doubled the speed of computers every 18 months. Okay?
Who has that?
Intel. So you think about that, compare it to automobile travel. Let's just say they've done it for the last 10 years, but it's been longer. What if we could double, for the last 10 years, we have doubled the speed of automobile travel, making it twice as fast, twice as safe, twice as reliable. Excuse me. So we'd be going how fast now? It would be 500-600 miles an hour. But if you could be traveling at 600 miles an hour in an automobile with lower crash rates, more economical like computers have gotten, just imagine the possibilities. Well, the same thing. What we can do now, in a year and a half from now, the core driving those things, speed will double and double. Okay. So that's the ability to process, to move information around. Now we've got two things here that can be a little confusing. First of all, we've got RAM, which is random access memory. Think about that as the thinking power of the machine. Okay? Let's say, Crystal, write this. Got a pen handy? Write this number down. Just write these digits down. 9899994. You got that? Okay, multiply that times 454522. Okay, now we want you to do that until you get down to 1. Multiply and then go down 1, and okay? We'll wait for you. Go ahead.
That's gonna take a while.
It'll take a while. Okay? Aaron, We want you to start at 1 and go up to where she is. So what do we just do with our time, assuming these young ladies' calculations are about the same? What do we do for the overall process? We cut it in half, right? So what if we had 2 more people doing it? And 4 more people? That's your thinking power. The more you ask the computer to do, the more RAM it will pull in to work on it. Multitasking. If you have a machine doing lots of different things at one time, it uses more RAM.
Is that like whenever you have too many things open at once?
Exactly.
PC, you gotta do that not forcibly, that's not a Mac. Control.
Yeah, you get too many things at one time and it basically runs out of RAM and it just locks up almost. You know, you're asking it to carry too many plates at one time and it slows down because you've got this real elaborate screensaver that's running in the background. You've got Facebook open, you've got CD or you've got iTunes playing, you've got 4 or 5 things playing, and you're doing something else. And pretty soon the machine's kind of juggling all this stuff. You don't have that much computer. Okay? We're going to be working on videos at the end of this session. Videos take a lot of RAM. Okay? We'll talk more about that. So you have to save a lot, and you have to have a big machine to do big video projects. So you've got RAM. Now that is random access. That's live memory. Okay? As opposed to the hard drive storage, which is stored on the hard drive permanently, right? It's unfortunate that RAM has memory in it, but the hard drive in the machine is where you store everything that's there forever, right? It's stored magnetically. So the RAM is, when you turn the machine off, RAM's gone. It clears it out. If you save something on the machine, it's there permanently. And it's magnetically. If you have a flash drive or something and you put it on a big speaker that has a big magnet in it, you can ruin all your data. Right? There's a great story of a guy who was one of the early computer hackers, and he'd stole a bunch of credit card information or something, and he did it all in his basement. But he built his basement only one way in, one way out, this hallway. And the FBI comes in, grabs all the stuff. When they wheel his computers out, he had high-powered electronic magnets lining the hallway, and they scrambled all the hard drives on their way out. So storage, you've got the hard drive, that's permanent. It looks kind of like an old CD. Okay, CDs, DVDs, just a different way of storing it. You know, we all use thumb drives, backup hard drives, and so on now. If you haven't gotten a pretty good thumb drive for this class, you really need one. Probably like at least an 8 gig or something. So, floppy disk. This is like history. I don't know why that's still on there. Mouse, keyboard. In the other class, we were talking about keyboarding and so on. And I have a 3-year-old, and you know, I know when she's 12, she's going to look at me and go, "You mean you guys used to bang on the? You used to go to a computer and bang with your fingers? What you like do this in your wagon crossing the plains or something? What? You know, in 10 years, she's going to walk up and go, "Hey, Jill," so she'll name her computer, of course, and they'll come on and go, "What can I help you with?" And she'll just ask a question, and they'll all spit out. She's not going to sit there and go, you know, what? She'll say, why did you do? I mean, she's doing this now at 3. You know, in 10 years, she's not going to have to do that nonsense. So that, you know, that's going to be, this will be a floppy disk to her. So monitors, liquid crystal displays, these monitors that we have. Some graphic designers still want to use a CRT, so they think it has a better, truer picture of colors. Liquid crystal displays, and the bonus question is CRT stands for? We'll leave it as a bonus question. Printers. 2 types, inkjet, laserjet. Which is cheaper to operate?
Laser.
Laser is cheaper to operate, yeah. Used to be a big difference in pricing. Laser printers used to be 10 times compared to an inkjet. But now they've come down, and per page, lasers are more economical. But the inkjets have gotten better. The inkjets actually have like a little spray can in there. if you take a magnifying glass, especially on an early inkjet, and look at it, the letters, they're spray. It's like a spray can. They're red, they're rough on the edges, whereas a laser printer actually shoots a straight line and puts the ink there. Okay, but now the inkjets are so good, and if you held them up, you'd be hard pressed to determine. You could probably do it, but before it was very obvious. One's a spray can and one's a straight shot. Okay. Speakers, yeah. Modems, yeah, we know. Okay, files and folders. You've done the electronic file management thing, right?
Yes.
The most important thing you will learn in this class, believe it or not, is electronic file management. Okay? I'm not sure she told you or not, but it happens every semester. Somebody runs across the hall. I've lost my 20-page paper. Where'd you put it? I've saved it. Where? On that computer. Where? What do you mean where? I put it on the computer. That's like saying I took one piece of paper and put it in Lamb Hall. Where'd you put it in Lamb Hall? I just put it in Lamb Hall. Which floor? I don't know. Which room? I don't know. Well, let's start looking for that one piece of paper, shall we? So, file management is incredibly important. It's not only good enough knowing where the stuff is, but you have to be able to find it. Okay? When somebody comes in your office and says, "Hey, do you have this?" You go, "Yeah, just a second. Let me follow my path statement, my filing directory, and I'll have it for you in 30 seconds." Or if you go, "Oh, let me try to look for it," and 20 minutes later they're standing in your doorway, they're not going to come back next time. Okay? And remember, people don't hire college students, they hire what? Solutions to problems. I've been teaching 23 years, and I get 4, maybe 5 calls a semester for jobs, and not one time has someone said, "I need to hire someone who can find a room in a big building from a parking lot and come sit in there for 15 weeks and write stuff down and memorize it. I need a couple of those. You got some?" I got a whole building full of them. They say, "I've got these 2 problems I need addressed." You got somebody who can do that? Yeah. So, being able to find the information and pass it on, that's what you're looking for. That's why this electronic file management is so, so important. Okay. So files and folders. And it's not learning how to click on a button and make a subfolder, right? I mean, Sailor Rose can almost do that at 3. That's not the point. The point is that you come up with a logic structure in your head that when you go at work and you show it to someone else, they go, "Well, that makes sense. Yeah, I can follow that. I don't have to have a lot of explanation." Okay? It's a good design. Have you talked about TED? You know what TED is? You got a TED.com. Okay? The best of everything, people in the world who whatever they do, they end up on TED. 15-minute lectures or so on, and it's technology, education, design. TED. So TED.com. Start watching a TED every day. But that's the design. You design a file structure so that when you show it to your staff, they go, "Well, sure." It becomes intuitive. Okay? So that's the whole file folder management. So at the end of the semester, when you do your presentation, if you load a flash drive up here and it takes you 5 minutes to find your presentation, just go over to drop an ad, drop the class, and sign up for next time. Because after the whole semester talking about file management, if you can't find your PowerPoint in the 13th week, we have failed you miserably. Go tell them you want your money back. We did a poor job. Okay? So, organize. And this is how Microsoft does it for you. Documents, pictures, music, videos, downloads. They just set those up for the average person. It kind of makes sense. Okay? Across the hall in my office, we have like 5 computers joined together. We have projects and courses. We have a shared file, and everything's either a project or a course. If it's a project, it's one of my projects, the dean's projects, the college, the university. So you just look at what you're doing, you go, oh, that's a Valley Brook project. So that's a project, college, Valley Brook, and you just keep following it till you find it. Okay? That describes the parts and the path statements and so on, the address bar. So look over that. It's probably something you've used all the time. You haven't taken time to learn the names of it. So look over that terminology. Copying, moving. You did all that with the electronic file management part. And the rest of this is pretty self-explanatory. Lost folders and so on. Questions about any of that? Pretty straightforward. Okay, so that sums up Intro to Computers.